and welcome to class. This is Mr. Michael Izanata here. In this video, we want to continue our study on mensuration of solid shapes. In the last class, we looked at some examples on some solids, namely the cube, the cuboid, and the cylinder. So in this video, we want to consider a sub-example on the cone. Alright, so we want to see how we can be able to calculate the slant height of a cone, the volume of a cone, and the surface area of a cone. So a question could come in this form. Let me make a drawing of a cone. So we have a cone represented by this, okay, having a base. So this cone is having a base diameter of 12 cm. In other words, the whole length of the circular base of the cone is 12 cm. All right, the 12 cm, that's it. So a cone has a base diameter of 12 cm, and it also has a height of 8 cm. So if we draw a height here, so it has a height, it has a height of, okay, it has a height of 8 cm. The 8 is clearly 8 cm. Okay, now we are to calculate the slant height. We are to calculate the slant height. The slant height we are to calculate the volume, and 3, we have to calculate the surface area of the cone. So the cone under consideration has a base radius, a base diameter of 12 cm and a height of 8 cm. We have to use the given information to calculate the slant height of the cone, the volume of the cone, and the surface area of the cone. Get the question? A cone is 8 cm high and has a base diameter of 12 cm. Calculate the slant height, the volume, and the surface area. So let's go ahead and see how we can solve this, but I'm going to make another drawing of this cone. But before I do that, now remember that in our cone, given that 12 cm is the length or the value of the base diameter, that's the diameter of the circular base of the cone, and we know that the diameter is 2 radii. When you multiply your radius by 2, you get a diameter. That means that a radius is equal to diameter over 2. When you divide, the half of diameter is radius. It means therefore that the value from here to here, which is the radius which we will need, we can easily get that by dividing the diameter by 2. So when we divide the diameter by 2, that will give us 6 cm as our radius. That will give us 6 cm as our radius. So I'm going to go ahead and make another drawing using the new information that we have. Alright, so let's consider that this is our cone here. This is the same cone. Okay, this is the same cone. Now, but we now know that the radius of this cone, r, and then we know the height of this cone. So the radius of the cone, the r, is 6. That is when you divide 12 by 2, 6. And the height of the cone is 8. Okay, let me just use the value. So we have the radius to be 6 and the height to be 8. Now the first question expects us to calculate the slant height. Now in the last one of the classes that we had, we found out that we can use Pythagoras theorem to calculate the slant height of a given cone. When we consider this triangle here, there's a right angle formed at this edge. All right, we know that the formula slant height as a L squared is given by radius squared plus the height squared. That is the formula we derived from one of our classes. So utilizing this formula for our slant height is L, so we have L squared is equal to our radius now is 6 squared plus our height, that is 8 squared. Our L squared is equal to 6 squared, that's 36, plus 64. It means that our L squared is equal to 100. L squared is equal to 100, and that means that our L, we're taking square root of both sides, we take root of both sides, our L is equal to the square root of 100, and that means that L is equal to 10. Therefore, the equation 1, which is asking us for the slant height of this cone, we know that the L, the slant height, therefore, is equal to 10 centimeter. That is 1. Alright, so what we did was to use the Pythagoras theorem to calculate the value of our L here, because when you consider this triangle, if I should bring it out, it's like we had this triangle, the radius being 6 and the height being 8, so we're left with this L. That is why we had to use Pythagoras theorem to solve that, and we have gotten the value of the L to be 10 centimeter, 10 cm here. That is that. Okay, now the next question is asking for the volume of this particular cone, the volume of the particular cone. Now we know that the volume formula for the volume of a cone, so if I were to solve for the volume of this cone, if I were to solve for the volume of the given cone, okay, having a base radius, having a radius of 6 and a height of 8, if I were to solve for, and then we have gotten the slant height. Now the slant height is 10. From the last example, we got the slant height to be 10. So going over to our variant, the volume of a cone is given by 1/3 pi r squared h. That's the volume of a cone. It's given by 1/3 pi r squared. That's the 1/3 of the volume of a cylinder. Remember that the pi r squared is the volume of a cylinder. Therefore, the volume of a cone is 1/3 of the volume of a cylinder. We'll go ahead and substitute our values. So our V volume now will be 1/3 times the pi. Our pi is always a constant, which is 22/7. 22/7 times our radius squared. Our radius is 6, so that's 6 times 6. Then times the height h, and our h is 8. We have our h is 8. Okay, 3 can cancel, 3 here, 1, 3 here, that will give us 2. Nothing can divide further, so we'll have to multiply through 22 times 2 times 6 times 8. That will give us, okay, that will give us 2112/7. We have 2112/7. Now 2112, that's 2112 divided by 7, approximately, that will give us 301.7 cm cube, 301.7 cm cube. Okay, so that's remember the units, cubic units, because we are dealing with volume. So the volume of this particular cone in question, having a base diameter of 12 cm and a height of 8 cm, the volume of the given cone under consideration is equal to 301.7 cm cube. Alright, now to the next one. We want to look at the surface area, the total surface area of this cone. We want to look at the total surface area of this cone. Alright, now if you recall the formula for the surface area of a cone, the formula is given by pi r l plus pi r square, or the other way around, you can say pi r squared plus pi r l. That's the base area plus the lateral area. The base area, that's the area of the circular top. That's the area of this circular top. That's the pi r squared. Then the pi r l is the area of the lateral side. When you now take into account this lateral side, you have the area of that. Alright, so we're having this to be the formula for the surface area of a cone, or you could even use the shortened version of it, as pi r into r plus l. And when you factorize, bringing your pi r and factorizing, you have the pi r into r plus l. They are the same thing, so this and this are the same. So anyone you choose to use, you're welcome. So going ahead to substitute the values, our pi, so I want to use this now. So our pi is given by 22/7 times the r, and the radius of the given cone is 6 cm. Opening our bracket, to have our r, which is 6, plus our l. The l is what's that l now? That's our l is the slant height, and the slant height, we got that to be 10 cm. Got that to be 10 cm. Okay, so multiplying it out, we have 22. Let me scroll down. Okay, so we'll still have 22/7. Have 22/7 times the 6 times, now for our bracket, we have 6 plus 10. We have to solve the bracket, so the 6 plus the 10 in the bracket, that will give us 16. So we have 22/7, that's our pi, times our 6, which is our r. Then in the bracket, our r plus our l, that's 6 plus 10, that would simplify to 16. We're having this. Then multiplying out, nothing can divide, so multiplying out 22 times 6 times 16, that would still give us 2112. Okay, so then 22 times 6 times 16, that will still give us 2112 divided by 7. So 2112 divided by 7, that will still give us approximately what we got earlier, which is 301.7 cm squared. The unit will be cm squared because we are dealing with area. We are dealing with area of the surface area. That's always a squared unit, whereas the volume would give you cubic unit. All right, so that's pretty much how we can solve problems on cone. So you could be asked to calculate the slant height, or to calculate the volume, or to calculate the surface area. There are other examples we could solve on this, but we will look at that in future classes. But for now, go through this, make sure you understand what we've just done, how we have used the Pythagoras theorem to evaluate the slant height, and how we have also solved the volume using the given formula for the volume of a cone, which is 1/3 pi r squared h. Then, of course, how we are also able to solve for the surface area of the cone using the formula. All right. Okay, so I will see you in the next video. For now, take care of yourselves and stay safe. Bye.